In this experiment, I analyzed the motion of an object with constant velocity and attempted to model its position over time in order to determine if Newton's second law could be used to predict the future location of moving objects. In order to create my model, I needed to use information from my experiment, such as the initial position vector, the final time, and initial velocity to initialize the conditions. Using the average velocity formula, v equals the change in position over the change in time, and the initial position in time, and the second position in time, I found the initial velocity of my object. I assumed there were no net interactions from the surroundings, so the net force would be zero. This also means that there is constant velocity. Because of these assumptions, my model more closely follows Newton's first law, in which there are balanced forces rather than the second law, where there's acceleration due to a net force. I had to replace some of my original code in my while loop so it could better predict the object's position and velocity. The position update formula was used in my model to determine the new position after every iteration of the while loop. Also, the velocity update formula was used in my model to determine the new velocity after every iteration. In this instance, that formula isn't necessary because the velocity is constant. This while loop was made using the principles of Newton's second law, in which velocity varies over time. Since the object is moving in the negative x direction, in my model I multiply the velocity times delta t by -1. Now here's a comparison between my object's motion on tracker and its motion from my computational model. So I'll start with going to tracker. And then here's my object's motion in my computational model. As shown in the graph, my computational model turned out to be accurate with a nearly identical slope as that of my experiments. The likely reason for this is that the time interval I was analyzing was considerably short, around less than a second, therefore there wouldn't be noticeable deviations from the experiment slope. After this experiment, from my comparison of the observed and model data, it has been proven that Newton's second law can be utilized to predict the future of objects in motion. Even though it wasn't apparent in my experiment, some sources of error could have been the non-uniform shape of my object that has a flat surface on one of its sides, my object moving in more than one direction, or how I recorded the frames of my object on tracker. Some questions for consideration were, is it possible to say how many forces were added to give zero net force? The answer is yes. There are three forces, friction, gravity, and air resistance, that all add up to give zero net force. How would results change if the x-axis was flipped? Aside from both lines for the experiment and model having a positive slope, the results wouldn't change if the object was moving in the positive x direction. That's about it. Thanks for watching.